G'day everybody and welcome to another Science Minute with Dr. Joe. Today I'd like to talk a bit about air pressure, which is one of the main themes of a new science fiction book that I'm bringing out soon. So can I have a helper? Carly, would you mind coming and help me out here please? My good friend Carly. Carly, do you know what this is?
A balloon.
What am I putting into the balloon?
Air.
Not yet. That's just a pump. Now we put the air in the balloon. Can you see the air?
No.
Oh, well, here's a good science question. How does the air make the balloon change shape? I'll give you a theory. One idea is that the air is made out of billions of little particles, like basketballs, that are bouncing around really fast. And all that bouncing, even though they're very small so you can push them out of the way very easily, so many of them are able to push the balloon outwards. We call that idea air pressure. It's one of the reasons why if we blow the balloon up a little bit more, you can do this. A little bit of air pressure. The air is pushing. How hard is it pushing? Right, Carly, you see this big bottle here? Right, what's this bottle full of?
Air.
That's right, it's full of air even when it's upside down. And air's, what's it doing?
Moving.
Bouncing violently around. You can't see it, but it really is. Now, how hard is it pushing? Do you reckon you could crush that air? Give it a go. It's something you can try at home too. Crush the air. Is that hard?
No.
No. But did she really crush the air? Look, it was getting out the top there. What do you say? We put the lid on the bottle, just like that. Now we'll give it a good hard squeeze. Do you reckon you can crush that? Is it a bit harder?
Yeah.
It's a lot harder. Not even an army of grown-ups couldn't crush that all together. See, as the more you squeeze, the more those particles bounce. Air is pushing, it's pushing very hard. Matter of fact, on the space of your hand like this, hold your hand like this. Right, on the space of your fingernail, it's about a kilogram worth of pressure. And there's 40, 50 kilograms of skin, you reckon that's 40 or 50 kilograms pushing down. How come your hand's not falling over? That's like having a grade 3 kid sitting on your hand all day. Why doesn't your hand just fall down? Could be lots of reasons. You think my muscles are strong enough? No, not even as a grown-up I couldn't hold my hand out there all day. It's because the little air particles are also bouncing underneath. So it's balanced. Yeah, it's good fun, isn't it? So air is pushing, it's pushing hard. We can actually use this, a little trick like this, to make the air push even harder. Alright, do you want to just try those gloves on? I actually need some hot water. Maybe some that we've prepared for earlier. Thank you, helper. This is boiling hot water, so you don't want to get this anywhere near you. You want a grown-up to help you out with this one. I'm going to pour the boiling hot water in there, and the boiling hot water is going to make those little air particles bounce even faster than they were bouncing before. So I put the lid on nice and tight. This is why Carly's got the gloves on there. Give it a shake to heat up the air. Alright, just give it a quick squeeze there. Easier or harder?
Harder.
A lot harder, isn't it? All those particles are now bouncing so hard that they're bouncing harder than the air in the room. Open the bottle, you can hear them escaping. You hear them getting out then? It's the sound of air pushing itself out, just like when you open a can of soft drink. Now there's less air bouncing in there. What's going to happen to the bottle?
Ooh, that's cool.
Yeah, as the air goes back down to normal, can you see here what's happening to our bottle? It's beginning a slow implosion. What is crushing that bottle?
Air.
Air from where?
Outside.
What, from the room here? That's absolutely right. The air in the room is what's crushing that bottle. See, air never sucks. It never pulls. It's only ever bouncing and pushing things. So when there's less air in here, the air in the room can crush that. Take away all the air in here, and the air in the room would crush that completely flat. We have a bit of fun with that. That's one of the problems. In the story, we make the claim that if you were to jump out of a spaceship without a space suit on, covering your whole body, you're in for a bit of trouble. Have you ever seen those cartoons where kids jump out of the spaceship wearing a helmet so they can breathe? And pyjamas? We want to see what would happen to them. We're going to use this. This is a vacuum tube here that takes away about 80% of the air. And this is what would happen to you if you went into space without a cushion of air touching every square centimetre of your skin. Do you know what the first animal in space was?
Was it like a dog?
It was a dog. A dog called Laika, which is Russian for Barker. So they wanted to see I wanted to learn what would happen if something went up into space that was alive. Would it live? Or would it explode? Or would it just die from all the radiation up there? So what they did is they got a couple of stray dogs and they chose the loudest of them, something called Barker, and they sent her into space, and they have apologised because they never planned for her to come back. So what they did is they got themselves a dog. Now we don't have a dog that we can put into a vacuum tube, thankfully, so we're going to use this dog here. Here's our little Laika, a heroic Russian space dog. Now Carly, watch him very closely, right? Where is the air?
Inside.
Inside. And what's the air doing?
Bouncing.
Bouncing. And where else is the air?
Outside.
Around the dog, bouncing. And what happens if you take away the air around a dog or around a person? Imagine going to space and there's no air near you. We're going to take away the air around the dog. What do you think will happen?
It might get bigger.
Yeah. Let's have a look, shall we? We'll pop little Laika here into the little vacuum tube here, and then we're going to get my other helper to turn on some vacuum here. And watch the dog. Can you see very closely what's happening to little Laika as the air disappears from around her? Can you see her starting to swap? I'll let the air back in. And there you go, she gets smaller. Fill that up again, and she gets bigger. And if we took away all the air around her, the air inside the dog is enough to rip her right open, make her explode. We could really have some fun with that, hey? I think she's too tough, the Russian space dog, for us today. We'll have to try again later. So there we go. And that's a few of the fun secrets about air pressure. Always pushing all the time, even though you can't feel it. And without it near your skin, your liquids would start to boil. Your eyes would swell up as the air pressure around them disappeared, and then they would explode. I think I need to get a balloon.
Whoa! What?